Good. Hi, welcome back to another Topaz related video. What I want to do in this video is tell you a little bit how you can use some of the latest AI models to work with input files in Topaz Editor. And that's what we're calling the TOPilot way of working. So I think I said in the very first tutorial about VS Code, one of the nice things about VS Code, and one of the reasons why it's a good editor to use with Topaz, is it's naturally set up to work with some of the modern AI models. So when you first install VS Code, it already comes with GitHub Copilot, a chat window for that built in. And then there are various extensions that are available for working with either Claude Code or ChatGPT's Codex directly inside VS Code. So of course, because VS Code can work with these AI tools, it naturally means that Topaz Editor can work with these AI tools as well. So what you'll find in the Topaz Editor window is you'll find a little submenu here, which is called the Topaz AI interface, which has got some information on how you can start to work with these. So the first thing that you'll find in those menus is a little help page. And so if you read that help page, it will tell you how to set up either Claude or Copilot or Codex to do this type of work. Now, we've done most of the testing in Claude, and that's just because I happen to have a Claude account. My Claude account is one of these standard $20 a month account, and it seems certainly at the current time that that's an infinite amount of credits to essentially work with the TOPilot way of working essentially full time. So we've been playing with this over a number of weeks, and I haven't got anywhere close to my credits yet. So Claude Code is the one that we've tested most extensively. If you want to just have a test of things to get started, the Codex way of working has got the advantage of you do get a few free credits that you can play with before you actually commit to an account. I'm not quite sure how much work you can do, but it's probably enough to do maybe a couple of Rietveld refinements in TOPilot. GitHub Copilot also has a free tier to it. Again, you get more credits for this, you can do more work, but I think Copilot is probably the least powerful of these AI models to use with Topaz. So if you're going to do this work seriously, then I would suggest you do get something like a Claude account. Okay, so as I say, everything on setting this up, there's a help page that's available in Topaz Editor. If you want a little bit more information, the type of things that we'll go through in the video, there is a tutorial for this on the web. And before I move on to the next slides, I do want to thank obviously two people who've been doing a lot of the work on TOPilot. That's Alan Coelho, of course, and Oliver Wagstaff, who's been doing a lot of the testing of these methods. So thanks to them. In terms of how the TOPilot system works, you'll probably remember that when we went through and we set up Topaz Editor for the first time, you had a question which said, do you want to install a set of Claude AI skills? And I recommended that you clicked yes to that question. If you accepted that question and you installed the skills, what will have happened is a folder called Topaz INP Writer will have been written on your computer, and it will have been written in this directory here, which is a Claude skills directory. And what the Topaz INP Writer folder contains is it contains all the information to teach Claude the skill of working with Topaz. And I say to teach Claude, but it turns out that even though we've written this skill for Claude, you can get Copilot and Codex to read from the same skills file. So you should be able to pick up on all the same information that's been designed for Claude using one of the other AI models. So if you look in that folder, you'll see a series of subfolders and files have been written there for you. The most important one in a way is the file called skill.md. And what skill.md does is it's a file, it's a human readable file, but it's really designed for Claude to read. It's a file that tells Claude the top level information on what Topaz is, what Topaz does, and how to work with Topaz. So the skill.md is a really important file. The second most important files probably are stored in this folder called references. So what references contains is a series of files which tell Claude the more detailed information on working with Topaz. So for example, how to do a Rietveld refinement, or how to deal with symmetry, or what the Topaz syntax is. So the files that are in the references folder, they've been developed in a number of ways. So we've done several things. One of the things is we've rewritten the Topaz manual into a format that's accessible to Claude. I say we, but Alan's of course done most of the work there. So there's a series of files in there which describe the Topaz manual in the way that Claude will find useful. Claude's also been taught something about the source code of Topaz, and in particular it knows the Topaz tree structure. So the Topaz tree structure is the hierarchy of different commands, which commands sit in which different part of an input file. So what makes up a correct Topaz syntax? So that information has been fed into references as well. So Claude fundamentally knows how Topaz works. We've also fed it information based on all of the example input files that are with the main Topaz distribution, all of the ones that sit on my web page. So it's seen an awful lot of previous input files. And we've also taught it from some of the various other teaching resources, information on the wiki, information on my web page. So Claude knows an awful lot about how Topaz works and how to work with Topaz. And then the second very important folder is this scripts folder. Now we'll talk about some of the problems of AI in a second, but of course I'm sure you know already that AI is incredible. It's an incredible tool. It can do some really remarkable things, but it can make mistakes. It can hallucinate, and it's often trying to please the user by coming up with an answer that they want to see. Now that's fine in some areas, but it's not fine in specific science areas like crystallography. So for example, the general AI models now, they already know a lot of crystallographic information, and if you tell them a structure in a space group, they can probably guess which Wyckoff sites the individual atoms are sitting on. So they can probably guess which parameters are appropriate to refine and which shouldn't be refined. But of course, guessing isn't enough for crystallography. That symmetry work needs to be done precisely. So what you'll find in scripts is a series of Python scripts which do some of the harder crystallography in a deterministic way for Claude. So for example, with symmetry, there are some Python scripts in there. If you feed it any CIF file or any structural file from a Topaz input file, they will analyze those files and they will work out what the Wyckoff positions are for the individual atoms and therefore what's allowed to be refined. So when the Topaz AI is working with the Topaz input file, it's not guessing the symmetry, it's actually doing it in a deterministic way based on what's in the scripts library. We've already seen that working actually. When we went through some of the demonstrations about the basic Topaz editor, we were doing things like right-clicking on a structure and saying symmetrize structure. And that symmetrized structure is using the same information that's in the scripts file that Claude is reading. So we've done an awful lot of work making sure that, for example, all of the CIF files processed by Claude are processed correctly. I can't say that we've got things 100% right, but we've got a test library of over 5,000 CIF files in all 230 space groups, and all of the ones that we've tested pass through absolutely correctly. And when I say all of the ones we've tested, it's Oliver that's been doing all the hard work there. So if everything's correct, Oliver is the person who's achieved that. If anything's wrong, then I'll take the blame for that. But certainly everything seems to be working as we would expect. There are also things in the script files, there are little routines that do things like check the syntax of a Topaz file after it's been created to make sure it's correct. So that's that file. And then example input files is probably what you'd expect. What we've done is we've created a set of curated input files. We've taken many of the examples from the online tutorials and we've gone through and we've annotated those files so that Topaz can look at a model input file and it can base its input files on those if it chooses to do so. And then the final couple of folders, templates. What I've been using Claude to do quite a lot is at the end of a Rietveld refinement, just automatically generate me a Word document with a report of that Rietveld refinement. And so what I keep in templates is the outline information that I want in that Word document, what I want reported in terms of R factors, tables, output of parameters, all those kinds of things. And then finally, test examples. We'll look at that in the tutorials a little bit. What there is in test examples is a series of half a dozen examples or so with some instructions for the AI, basically saying, do this bit of powdered diffraction analysis. And if you just ask Claude to read that file, you can watch it doing the analysis. So that's the bare bones of what's going on. Before we switch into sort of example mode, the obvious slide at the end, I think this is probably a bit patronizing for people, but I feel I should say it. Obviously, a bit of a warning and a disclaimer. I've said already that the modern AI models are incredibly powerful, but they can make mistakes. With the TOPilot way of working, as I said, with these Python scripts, we've done as much as we can to try and make sure that those mistakes don't happen and that they aren't critical crystallographic errors. But there will always be mistakes with any AI model that you use. So I would suggest that the TOPilot way of working, certainly for the time being, use it as a tool, something that's really useful, something that will speed up your work, but don't necessarily trust it as a source of absolute truth. As with any AI models, any AI way of working, the more defined the task you give to the AI, the more likely it is to give you a sensible answer. So, for example, if you say to TOPilot, can you explain this part of an input file for me? It will consult the manual and it will almost certainly get that right. If you give it a very broad description, like analyze this powder pattern, it may not know what to do. So it may go off and do some analysis that isn't what you were expecting it to do. And so again, patronizingly, if you're working on a piece of powder diffraction analysis, you should remember that ultimately it's going to be your name that appears on the paper or the thesis or the report that you give your bosses. So as with any Topaz work, ultimately you are responsible for the scientific content of what's in the input file, and therefore the scientific content of any report that's created. Okay, so that's all I want to say in overview. What we'll do next is we'll switch into Topaz Editor, and I'll just go through a very few quick examples of how you can get TOPilot to work with Topaz. I'm not going to sit for hours and hours and hours showing you how to interact with an AI model, because I think that's something that other people know far better than me. So we'll run through a couple of very quick examples, and then what I might do afterwards is I'll just append to the end of the video some of the test examples distributed with TOPilot, and I'll just run those through in a sped up way, so maybe in a couple of minutes you can see TOPilot doing different types of analysis from start to finish. Okay, so ultimately I'll just finish this section with the warning that you're responsible for everything that's done in one of these input files. Think of TOPilot as something that's going to be very useful. It can speed up the work that you're doing enormously. It can automate lots of types of analysis in a very, very powerful and efficient way. But ultimately, you're responsible for the scientific outputs. So what we'll do next is we'll switch to Topaz Editor and run through some of the examples. Okay, so here we are back in Topaz Editor, and we're just going to have a quick look at the TOPilot AI interface. As I say, we won't try and do too much interactively, but I'll put some sped up videos at the end. So because we're working with TOPilot, let's open the TOPilot menus. The first item in there is this help menu. So if we look at the help menu, it tells you how to set up Claude to work with TOPilot, how to set up GitHub Copilot to work with TOPilot, and then how to set up Codex to work with TOPilot. So I've already set up Claude on my computer. So if I go to my extensions panel here, you can see Claude Code has been installed. So 22 million people have installed Claude Code so far, slightly more than Topaz Editor, but we'll get there one day. First thing that we should always do, because TOPilot is evolving quite quickly at the moment, it's always worth clicking on this Install Update Skills button. So if I click on that, it tells me that my skills are up to date, so that's fine. If they're not up to date, then it'll prompt you to download a new set of skills. Good. So what should we do? Let's just start with something very simple, and let's just open an input file. And this input file that I've just opened is the input file that we created in the standard Topaz Editor menus when we set up the Rietveld refinement for Rutile. So it's the first input file that gets set up when you click through all of the standard commands. But let's see what we can do with TOPilot with that file. So in the top right here, I can click on this little orange star, and what that will do is open a Claude Code panel, and I can just type commands into this panel to work with input files. And let me say to Claude, what skills do you have? And then we should be able to find out if it knows about the Topaz skills or not. And then while it's doing that, so it's come back to us already and it said, yes, I know about the Topaz Imp-Writer skills, and that's for working with Topaz Academic. So that's great. So let's say to it, summarize this imp file. And hopefully what it'll do is it should be able to go away, and based on its skills, it should read through the input file, have a think about it, check it against some of the Topaz conventions it knows, and then come back with some kind of a summary of the file. So it's sitting there thinking for a little bit. So I'll just turn off my camera while it's thinking, and then we'll be able to speed things up so that I don't jump around. Actually, just before I go, you can see that what it's done is it's running a little syntax checker on the input file in the background. And that's one of these Python scripts that I told you about that just checks that the file is a valid Topaz file. Okay, so you can see now that it's come back and it's thought about that file, and it's giving us a little summary of that starting file. So it says it's a single phase Rietveld refinement for rutile. It's explaining the name of the data file. It's explaining the type of diffractometer that's been using. It's explaining the emission profile. It's worked out the structural information and where the atoms are sitting. It knows that just the scale factor is refining. It understands the peak shape parameters in the file, and it knows about what the various terms like chi-squared under chi2 underscore convergence means. And then it's given us a little warning at the moment. It says, oh, this is a stage 1 file, nothing's been refined yet, no lattice parameters or anything else. It's warning us about the unit cell parameters. When you do refine the cell, make sure that B and A are set equal to each other, because it knows it's a tetragonal system. It knows the peak shape is being refined, and it knows that Topaz doesn't actually need the cell angles because it will assume that they're correct. So it's checked that file and it's given us a really useful summary of it. So let's say to it, please set the atomic coordinates and the unit cell parameters to refine as allowed by symmetry. See what happens. Okay, so it's done an awful lot of work at that time. What it's been doing is it's worked out the various symmetry problems, and it's changed the it's added a parameter name for the A cell parameter. It's set the B to be equal to the value of A. It's set the C to have its own independent parameter. It's gone through and it's set up the ties on the oxygen coordinates so that atom stays on x0, sorry. It rechecked the syntax in the file. It rechecked the symmetry to make sure everything was correct. It's probably doing more checks than it needs to at this point, and it made sure that the syntax was still correct. So it basically has worked out for us that there's only actually 3 extra parameters that are possible: the A parameter, the C parameter, and the oxygen X value. So that's great. So it's updated the input file on the left, and you can see that now all of the atoms are set to refine by symmetry. There's lots of things we could do now. What we could say is we could say to it, run a Rietveld refinement, then create an interactive plot I can look at with tick marks. Okay, so we can set it off to do that. And so what it will probably try and do, it will run that file through Topaz. It will run it through tc.exe. It will hopefully realize that if it's going to have to make an interactive plot, it's going to write its own, use one of its own tools for making that plot for us. So it should realize it has to write out the observed and calculated X-ray patterns at the end of the refinement. And then it'll also need to write out a file with the tick marks so it can plot. So at the moment it's gone away and it's found where the main Topaz executable is sitting, and it's going to go off and do its work. So let's leave it to do its work for a second or two. Okay, so what's just happened there, you can see the various things that happened that flashed through on the screen. So as we said, it put some lines into the Topaz file to write the XY files out at the end. It created some tick marks for us. It went off and it ran Topaz, and we can see that got an R factor of 14% at the end of the refinement. It wrote the tick marks, it looked at the format, and then it built an interactive plot. And what you probably saw jump up on the screen was a HTML file which contains the final plots. We'll have a look at that in a second, but just while it's after it had written that plot, you can see it summarized the refinement for us on the screen. And while we're looking at the plot, let's just ask it to write a Word document containing a report of the refinement. So let's send that command off, and it'll hopefully work on that just while we're looking at the screen. So the way that it writes a Rietveld plot is it writes a little HTML file. So what it opened for us automatically was this HTML file that's on the screen here. So it's just a simple interactive Rietveld view. So we can zoom in on a peak if we want to inspect the peak. We can slide left and right across the pattern. If we hover over one of these tick marks, it will hopefully show us. Sorry, my mouse is a little bit big just for the demonstrations, but hopefully you can see that underneath that tick mark, we get a little label saying this is the Rutile 200, this is the Rutile 101 reflection. So it's a very crude structural viewer, but that gets launched for you automatically. You can do things like you can plot on a square root Y scale if you want to. You can get rid of the difference plot. You can get rid of the calculated plot. Okay, so let's go back to Topaz Editor and see what's happened. Oh, it's asked us to run Topaz again. Because we're doing a final analysis on the Rietveld file, what it realizes is we probably need to look at some errors in the model. So it's going to rerun the refinement with the errors turned on. And so that will just take it a few seconds while it does that and creates the Word report for us again. Okay, so Claude did quite a lot of work there. Because we asked it for a full report on the Rietveld refinement, what it decided to do was to follow the instructions of how to do a Rietveld refinement that we've taught it. So it's gone away and it's refined the background parameters, the axial parameter, the 0-point error. It's refined the unit cell parameters according to symmetry. It's refined the oxygen coordinate. And you probably saw, if you look through the video, it refined the peak shape parameters. It checked to see if there was a false minimum. And it also calculated the errors for the refinement. So as it did all of that, it produced a series of interactive reports for us. It made the Rietveld plot that we've looked at already. So that should be open in our editor. We've looked at that one already. It also made a little heat map of the correlation matrix, so we can look at the correlations in the refinement just the same way that you would in Topaz. And then finally, it made a report in Word, which has just appeared on my other screen. So if I drag that across, is a report of the Rietveld refinement. So it's written up the date that the work was done. It's written up the name of the data set, the range of data refined, how many points there were, what the software used was. It's described for us the structural model. It's described exactly how it did the refinement, all of the terms in the refinement. It's counted the number of refined parameters for us. It's giving us a nice table which contains the fractional coordinates, and at the moment it's fixed the temperature factors, but we could have asked it to go back and refine those temperature factors. And then the lattice parameters have been reported for us, and it's done a calculation of the bond lengths and angles, and it's summarized the peak shape and the instrumental parameters for us in a separate table. And the statistics of the refinement have been reported in a table here. It tells us about doing a false minimum check on the peak shape parameters, which is nice. It's given us some warnings about the refinement, things to look at, terms which are quite highly correlated that we might need to worry about. And then it's produced a little figure here of the final Rietveld fit, which is just put into the report for us. It's told us where these interactive plots are sitting if we want. It's told us the names of the files that it's created, and it's given us this little warning at the bottom here saying this refinement was performed with TOPilot, so it's your responsibility to check its scientific content. There's one other thing that it did for us. It said on the screen here that our topaz launch file.txt now contains points at the final Rietveld refinement. That means that in Topaz Editor, if I just open a Topaz by doing a Control-TA, I'm just launching Topaz, and as always, it's appearing on my other screen, so I'll drag it across to this screen. And what you'll see is automatically Topaz knows this the input file that's just been run. So if we run that refinement in Topaz, we can very quickly inspect that file in just the way we would any other Topaz refinement. So for example, if I put the tick marks on, we can look at that in just the normal way. Okay, so that's TOPilot doing something that's relatively straightforward, but it's doing it already in quite a sophisticated way. So let's stop at that point and then we'll look at another example in a second. Okay, let's try a slightly simpler example this time. What I'm going to do is I'm going to open an input file which is called d5005 _messedup.imp. And this is the kind of input file that I'm frequently sent by people when they say things like, my input file doesn't work. Can you fix it for me? So let's have a go at that. So let's just say to Claude, I was sent this file by let's say a bad friend and it won't run. Can you fix it for me? Okay, so let's let it work. So as I say, while it's working, let's just have a little look at the file ourselves. It's the kind of file I'm often sent. It's kind of messy in that it doesn't have any nice indentation, any nice alignment so that you can work out easily what's going on in the file. But if we look at it, there's some clear problems. This little 0 point macro here, it's not been highlighted in dark blue. And so clearly Topaz Editor isn't recognizing that as a known Topaz macro. And that's because the real macro for 0 point is 0_error, not 0 point. So that's clearly wrong. What else is slightly odd? So we've got things like, here's a section which defines the X-ray data set. So that's the name of the X-ray data set. But things like the wavelength and the 0 point have been defined before the Topaz has been told the name of the file. So that's clearly going to be a problem as well. We've got information in here, Forstras. Forstras is information that's applied to every structural model. And equally, these lines here, the space group, the phase name, and the scale, they have to belong to a structural model. But actually, they've been defined before the str keyword. So there's all kinds of problems in that file. Hopefully, a combination of what TOPilot knows about the correct syntax of a Topaz file, the hierarchy of a Topaz file, what it's learned from the manual about what commands can go where. I'm going to let it look at that file and try and work out where the problems are and then work out how to fix it. And so it will either just make those files directly, or it will perhaps test them against Topaz, see where the errors come, and then correct accordingly. So let's leave it to do its work. Okay, so that's done. So you can see what's happened on the screen here. And we've now got a nice input file set up on the screen, and it's got beautiful indentations. So the information under the XDD is tabbed in one level, and then the information under the STR is tabbed in another level, so it's easy to read, and the full STR's information has been written at the bottom of the file. So TOPilot has made us a nice little summary of what's going on. It fixed this 0-point error. It moved the information to the right part of the file, and then it actually ran the file against Topaz, and it worked out that the final R factor was what you would expect for this particular data file. And then at the end, it's asking, well, do you want to see the final fit? I don't think we need to do that because it's clear that TOPilot has solved the problem. That's a little bit of an artificial problem in that this is a file that we were working on a few seconds ago, so TOPilot had some knowledge of it, but even in general cases, it's able to figure out these kind of syntax errors in input files. Okay, so in the examples on titanium dioxide, what we did was we deliberately got TOPilot to work with a pre-written input file, and we looked at how you can interact with pre-written input files. What we'll do in this example is something a little bit different. What we'll do is we'll try and get TOPilot to create an input file from scratch for us. So I've got a very simple example. So in this folder, I've just got a structural model for zirconium tungstate. Down behind my head here is zrw208.cif. And I've got a data file, a laboratory powder diffraction pattern for zirconium tungstate in the same folder. So all we'll do in Claude on the right here is I'll paste in some instructions to ask it to set up an input file to do a simple Rietveld refinement. So I've pasted the instructions in the right-hand window. It knows to use the Topaz input writer skill, and it's gone off to try and create that input file for us. Okay, so let's just have a look at the prompt that I gave it. So the prompt was, don't look at any of the files in this folder for clues. So try and make things up from scratch, or create things from scratch. I shouldn't say make up. I've got a data file called zirconium tungstate.raw, and I've got a structural model in zirconium tungstate.cif. So create and open a simple input file for Rietveld refinement. No need to check it, no need to run it through Topaz. Okay, so a minimal set of instructions. So one of the key things about those instructions is I haven't told TOPilot anything about the instrument that the data was recorded on. I've not told it the wavelength that was used. I've not told it anything about the monochromator, and I've not told it anything about the slit setup. So the way that we've written TOPilot is if any of those key experimental details are unsure, it ought to come back and prompt the reader for more information. And you can see that's exactly what it's done. So it's saying, well, it knows it's a copper K-alpha 1, K-alpha 2 experiment. It's got that from the data files, but it doesn't know anything about the monochromator or about the slits used. And so it's given us some choices. And in fact, this particular experiment was a copper K-alpha 1, K-alpha 2 diffractometer. There was no monochromator and variable slits were used. So it's asked us a sensible prompt. So let's choose this option. And then for the peak shape, we could ask it just to make its own decisions about the best peak shape to use, but I prefer it if it comes back and asks me. So let's do a simple TCHZ pseudo-void peak shape for this particular example. Okay, so it knows what to do now, and it's going off and it's looking for how to set up an input file. And we can see here in the example input files folder, it's found a typical input file for a laboratory diffractometer, so it will probably use that as the basis for how it sets up the input file for zirconium tungstate. So it's read that, and now it's thinking about the problem, and it's reading the structural information, etc. So let's just leave it for a second to do its work. We'll come back and see it in a minute or so. Okay, so we can see at this point that it's come back and it's created some kind of an input file for us. It's made a little report on the right-hand side of what it's done, but let's just look through it ourselves. So here's a little header saying this is the type of Rietveld refinement we want to do. We've got the R factors written in with zeros at the top of the file. Those will be updated after the refinement. Some information on the number of cycles, etc. to do. It's got the name of the data set correctly here. It's doing a 6-order Chebyshev background polynomial. Because it's a simple Rietveld refinement, it's just choosing to restrict the data range for the first cycles. It's chosen the right LP factor for this particular setup based on the prompt that it gave us. It's chosen to use this emission profile, copper K-alpha2 analytical profile, and that's the correct one to use if you're using a TCHZ peak shape model. It knows about the variable divergence intensity slits. It's got a simple asymmetry correction in there. It's decided to refine a specimen displacement. That's what you would normally do with lab data. And then for the phase itself, what it's chosen to do is it's set things up so that the cubic cell parameter of the material is refined, but A and B are related to it. It's got the space group here. And if we look at the atomic coordinates, it's worked out the symmetry correctly. So for atoms on a threefold axis like the zirconium, it's saying the x coordinate can refine and y and z have to be the same as x. And then for atoms on a general position like oxygen 1, those are free to refine. So, and then at the end, it's set up the peak shape for this particular example. So we could interact further with TOPilot, and we could say, well, go ahead and refine that that starting model for us and build a full Rietveld refinement. But just to see if it works, let's just do things ourselves, and let's just send this input file directly to Topaz. And then if we switch to the Topaz academic window, we can see here that the file that we've just created is the one that Topaz is going to read. And hopefully if I press this little run button, we should get the Rietveld refinement working straight away. So a moment of trepidation, has TOPilot got things correct? So let me click this play button, and you can see very quickly that, yes, it does look like TOPilot has got things correct. We've got a beautiful Rietveld fit here, or certainly a very good fit for a starting model. And we could go on and we could build that Rietveld refinement further, either ourselves working in Topaz Editor, or we could get TOPilot to do the work for us. So we'll stop the example at that point, and hopefully it's given you an idea that you can very quickly go from just some basic information to creating an input file for Rietveld refinement. Okay, so those are all the examples that I wanted to work through interactively. What I'll do now for the rest of the video is I'll just work through some of the various test examples and some of the examples from the online tutorials, and I'll just play through those analyses at a sped up speed so you can just get a feel for how TOPilot works on different types of problems. So I'll leave those running. As I said earlier, there won't be any voiceover on them because I don't want to sound like a squeaky Mickey Mouse. So I'll just let you watch those. Okay, so I'll say farewell at this point, and thanks for watching another Topaz video.